Welcome to calculus. Being challenged has a whole new meaning. On this episode, Stevenson will demonstrate You've heard me before talk about on the calculator parametric functions. Well, a parametric function is essentially a function that's defined by a third value. So, you know how we normally have functions like y equals a function of x? We have two variables. Well, in a parametric function, usually a curve, both x and y are separate and they're defined by a common variable, usually t. So a parameterized, that's not going to be successful. Curve is differentiable at t if and only if x and y are differentiable at t. So at the point on a differentiable parameterized curve where y is also a differentiable function of x, the derivative dy dt, dx dt, and dy dx are related by the chain rule. So if I want dy dt, I'm essentially going to do dy dx times dx dt. Now, finding the derivative parametrically looks complicated. It's actually very straightforward. If you know that dx dt, dy dt, and dy dx exist, and that dx dt is not zero, then if you want the derivative of a parametric function, all you have to do is do the derivative of the y function with respect to t and divide it by the derivative of the x function with respect to t. It's literally just the derivatives of x and y individually, and then you divide them. This is a parametric function. How do we know? Look at how it's defined. X is its own function of t and y is its own function of t. So we're trying to figure out what's the derivative of this parametric function at a particular value. So remember the derivative of a parametric. So we're going to find the derivatives individually and then divide. Now I highly recommend lead with y first, because then you'll see as you do your work, it'll naturally set up just like the form here. When I go to do the derivative of y, do you recognize this is the chain rule? The derivative of the outside, which is cosine, with the inside left alone, 2 pi t, times the derivative of the inside, which is 2 pi. Let's rewrite this. Let's move 2 pi out front. I now have y prime. Let's evaluate it at -1/6. Let's refer to our unit circle now. Negative pi over 3 just means the angle's going in a counterclockwise, or excuse me, a clockwise direction. So negative pi over 3 would be 1 pi over 3 this way, which would be right here. And the sign of that would be negative radical 3 over 2. If we simplify, we end up with radical 3 times pi. Now let's do x. Again, we're going to do our derivative here, but do you recognize sine has another function inside of it, therefore chain rule applies. Now let's evaluate our derivative at t equals -1/6. Again, let's go to our unit circle. The angle is negative pi over 3, so again, we're going to go into quadrant 4 here, 1 unit of pi over 3, which will be at 5 pi over 3. Cosine is the x-coordinate, and I can see it's positive 1/2. I have my y prime evaluated, I have my x prime evaluated. Now I can put them together as a quotient. Here's a practice problem to try. So this is a parametric equation, and the reason I know it's a parametric equation is because, again, I have x as a function of t, and I have y as a function of t. So I'm going to apply the rule of parametric derivatives here. What that means is we're going to do the derivative of x by itself, the derivative of y by itself, and find its quotient. So this is a practice problem, so go ahead and pause now and see what you can get. Let's see how we did. I'm going to start with y, and I'm going to evaluate at -1. Now let's do x. Now I'm going to evaluate my derivative My last step is to take my y prime and divide it by my x prime.